this idea of the squeeze theorem will explain why we get the answers we get. And it is as simple as this. It's just to show you what's really going on. Well, you have three functions here. And the limit of f of x as x approaches some value of b, which is the x coordinate right here, is going to equal L, the limit. And likewise, that is also going to equal the limit as x approaches some value b of g of x, right here. All right. That is also going to equal L, right? So the idea is that if you introduce this new function h of x, going through this point b and L, right? Let's see if I could write it somewhere. The limit as x approaches b of h of x must also equal to this value L, which is seen right here for both functions. So that's the idea behind the squeeze theorem. Now, let's get to a couple of trig functions that we're going to find the answer to. The limit as theta approaches 0 of sine of this function is going to be equal to 1. These and these cancel, right? And this 1, right, is going to be squeezed. There's a pattern here, guys, so I hope you see the pattern that's coming up. The limit as x approaches 0, this function is 3/4. And by the squeeze theorem also, right? So the argument is divided by, some arbitrary value times x is just going to be the coefficients. Also, before I move on, the squeeze theorem works well with tangent and sine, and we're going to see why. Cosine is a little bit more weird. The limit as x approaches 0, this function is going to be 2. And it's going to be squeezed also. Why? The argument of tan is just 1. And this is 2. So we take the coefficient. So this is 2 divided by 1. Let's look at this one. What do you think this one will be? Well, tangent of 3x divided by sine of 8x, again, is a coefficient. So the limit is going to be 3/8. And there's going to be a pattern here that you guys will see. What about this one? The limit as x approaches 0, sine of 5x divided by sine of 4x. Again, the coefficients. And it's the reason behind this is a squeeze theorem. Look at this one. The limit as h approaches 0, h divided by sine 3 of h is going to be 1/3. Again, by the squeeze theorem. Right? So this h and h cancel, which gives us the coefficient of 1/3, right? Let's look at some more examples. Let's look at this one. The limit as x theta approaches 0 of 1 minus cosine of theta divided by 2 sine of theta. Now, remember we said cosine is a little bit more tricky. All right, so looking at this, we can't just, there's nothing to squeeze here. We could squeeze tangent and sine, not cosine, and we also have a 1 minus here. So the first thing I'm going to do, because here we have a case of 0 over 0, right? Because remember, cosine of 0 is actually 1 and not 0, like sine. Tangent of 0 is 0, sine of 0 is 0. So we have an indeterminate form. So we got to go to our what do we know when we have something indeterminate. We could factor. We can't factor anything here. We can multiply by conjugate, possibly. So let's see. Well, 1 plus cosine theta, right? Whatever doing the top, doing the bottom. 1 plus cosine of theta, right? Doing that, there's going to be a limit as theta approaches 0 of 1, and we can multiply whatever we multiply by the conjugate by, right? So 1 plus cosine squared of theta divided by sine 2 theta times 1 plus cosine of theta, right? I'm sorry, this should be a minus, 1 minus, right? Because minus times a plus is just negative. All right, sorry about that. All right, so now what can we do? We want to see if we could squeeze something here Again, we can't squeeze anything. But a trig identity says that the limit as theta approaches 0, 1 minus cosine squared of theta is actually sine squared of theta. All right, that's a trig identity. Sine squared of theta divided by sine 2 theta 1 plus cosine theta. Now, here's a little nifty trick that I want you guys to know. Anytime you guys deal with squeeze theorem limits, anytime you have some squared value of a sine or tangent or anything, you want to always factor that out to its most factored form. So essentially, what do I mean? Well, this sine squared of theta could also be written as sine of theta times sine of theta. Yes? And now we could say, well, this is over sine 2 theta multiplied by this is 1 plus cosine of theta. See, this right here is the same thing as this. These two right here. This right here. We just factor them out. And so you want to make sure these go in the most factored form, or else you're not going to get the correct answer. Now looking at this, I could say, okay, well, can I squeeze something? Yes, I can. The sine theta over 2 sine theta is basically 1/2, because that's squeezed to 1/2. All right. And the sine theta, well, sine of 0 is just 0. And we no longer have indeterminate form. Well, 1 plus cosine of 0 is just 1, 2. Well, you have 1 right here. Cosine of 0 is 1. So you have 1 plus 1, which is 2. So anything divided by 0 is 0. So this is 0, but 1/2 times 0 is 0. So the limit for this is 0. So the squeeze theorem is very important, and it's denoted by the squeeze theorem right here. Let's look at the last one. Sine 3 of x cotangent of 5 of x. What the hell is this saying? Well, let's solve it. The limit as x approaches 0 of sine 3 of x. And remember, we could only squeeze. Well, not only squeeze, but majority of the times we want to get everything in terms of tangent and sine. So this cotangent of 5x could be written two ways. It could be written as cosine over sine 5x, or 1 over tangent of 5x. Now I'm going to choose 1 over tangent of 5x because, again, that's the conception, right? You want to get things in terms of sine and tangent, right? And that is divided by this x. This x is multiplied this cotangent of 4x. I could rewrite this as 1 over tangent of 4x. Same thing that I have here is the same thing up here. No, distributing, right? The limit as x approaches 0 now becomes sine 3 of x times tangent of 5x divided by x over tangent of 4x. And now I see something like this. I'm getting happier. So the limit as x approaches 0, we just flip and multiply. So this now becomes sine 3 of x divided by tangent of 5x multiplied by flipping tangent of 4x over x. And look, this now becomes a squeeze problem. This value right here is 3/5, right? Because tangent of 3x, that's squeezed to 3/5. Multiplied by, well, this is 4. And this is squeezed to 4 over 1, right? So we can now see that our limit is actually 12 over 5. So this squeeze theorem is very important. You should see that this x and tangent of 4x are just the coefficients. So you take the 1 and the 4, which gives you 1/4.